Hello everyone, welcome to AP Physics, Mastering Vectors in Minutes. In this video, I am going to go over vectors basics. So, what is a vector? A vector, unlike scalar, contains both magnitude and direction. So for example, speed is a scalar quantity and velocity is a vector quantity. So if you say your car is traveling 50 kilometers per hour, you are referring to its speed or the scalar quantity. However, if you are describing that your car is traveling 50 kilometers per hour west, you are referring to its velocity or a vector component. Expressing vectors graphically. So here we have two examples. So how do you express these vectors? Well, usually we are going to be on a plane of coordinates in some sort. So let's just look at one axis first. So in this, we can actually put whatever that we want for axes. Most likely it'll be west and east, or minus x on one side and x on the other side. And for each vector, the length of the arrow represents the magnitude of the vector, and the direction it points is where the vector is going. When a vector getting expressed in 2D, you would see it being expressed in x and y coordinates as shown here. Now normally in your tests, most of your vector problems would be in these type of plots, and the vector will be displayed the same, where the length of the arrow represents the magnitude, and direction of where the arrow points to is where the vector is heading towards. Now there are also third dimension in which there is the z-axis on top of that, but 3D dimensions are out of the scope of what I'm going to talk about in this video. So, of course, in your test, you would not just figuring out what is a vector and what is a scalar. How does a vector look like, right? This is physics, so there must be having math involved. So usually it starts off with analyzing these vector components or doing addition and subtraction. In this case, the most basics of analyzing vector is to dissect it into x and y components. So how do we do that? Let's look at an example. Well, here we got a vector of 5 meters, and it is at a 53 degrees on the polar coordinate system. So how do we figure out the x and y components for it? Well, for the x component, if you look at our formulas to the right-hand side, we see that for the x component, the formula is the vector magnitude times cosine of theta. So, well, theta is the angle of the vector in the polar coordinate system. So, if we substitute this, we would have 5 meters times cosine 53 degrees, which equates about to 3 meters. And of course, from trigonometry, you know that y component equates to the vector magnitude times sine theta, which if you substitute all of it into the equation, it equates to 5 times sine 53 degrees, or it equates to relatively to 4 meters. And thank you for listening to our video. This concludes the lecture. If you are interested in more studying materials, please download our physics app and other AP course study apps. This can be found in the links in our video description through YouTube. Also, if you want to keep up to date with our latest videos for studying purposes, please subscribe to our YouTube channel, and please share our videos via Twitter and Facebook. Thank you.